In this video, we're going to be moving from definite integrals, which is shown here on the left, and the Riemann summation notation, which is shown on the right. Now, the Riemann sum notation, I've seen it written both in white and in pink, and these things mean the same. All right, in that parentheses, a plus k delta x, or f of x sub I. Whenever you're dealing with this topic, I and k are used interchangeably. So this could easily be x sub k instead of x sub I. The x sub I refers to which x value you are plugging in to f of x to get that y value. And this is going to change based on how many delta x's you are moving from the starting point, which is a. So if you move k delta x's away from the a, you will be at this x value. But throughout the video, we're going to be using this white notation. And I'm going to be using k rather than I. Now, folks, this is how I like to think of it. When you have the integral, you have f of normal x. When you move to the summation notation, you're going to have f of what I call x on steroids. Okay, x on steroids. That is what's going to go in that parentheses. This a value is going to come from the definite integral. The delta x is going to come from this formula, b minus a divided by n intervals. And that's how we're going to convert back and forth. In our first example, we are given the Riemann sum notation, and we want to move to the integral. Okay, to move to the integral, we have to find the a and the b value, and we're going to take this x on steroids. Let me use a better color. This is f of x on steroids, and we're going to change that to simply f of x. Okay, we're going to use what they give us inside this parentheses, this x on steroids, to get our a value, and then use that to get the b value. Now, referring to this formula here on the right, we could see that this is our delta x right here. Here's our k value, here's our delta x, and this is our a value. So this matches here in the blue. So we know our a value is 2. Okay, so we know our a value is 2. We know that b minus a over n equals delta x, and we know our delta x is 3 over n. Therefore, we can match these numerators. B minus a and 3 are matched. We know our a value is 2. That's because they give it to us in the Riemann summation. So we have b minus 2 equals 3. Therefore, b equals 5. So our final answer is the summation from 2 to 5 of f of x times dx. Next, we are given the definite integral, and we're asked to find the summation notation. First thing we're going to do, folks, is recognize that this x, when we go to the Riemann notation, is going to become x on steroids. So we have to identify a, k, and delta x. Okay, a they give us, b they give us. We're going to use that to find delta x. So here we go. We have b minus a over n is going to equal 5 minus 1 over n, and that's going to be 4 over n. That is our delta x. Okay. So we're going to have our a value equals 1. We got that from the definite integral. And now we know that delta x equals 4 over n. So now we're going to redo our summation notation with those variables identified. Okay, so now we're going to have f of 1 plus k times 4 over n times 4 over n. And this goes in its separate bracket. That's our delta x shown here. There's our delta x shown there. The k is there, and that is our a value. And sometimes you'll see this very simple simplification, changing this to 4k over n within the parentheses. Next, we are given this definite integral, but now we have an actual function. We're not using theoretic f of x. And our actual function is sine of x. So folks, we're going to change this when we go to the Riemann sum to the sine of x on steroids. All right, how are we going to do that? Well, we're going to get our a value, which is shown here, and we got to get our delta x. Recall that b minus a over n gives us our delta x. We have the a value. The a value is 2. So we know, and we have the b value. So we know that b, which is 4, minus a, which is 2, over n equals 2 over n. That is our delta x. So we have our a, we have our delta x. We can now build our f of x on steroids. So here we go. We're going to have our summation symbol here, k equals 1 to n, and the limit is out here as n goes to infinity. Okay, let's build, and don't forget our delta x here. Okay, let's build the x on steroids. We're going to start with the a value. We got that from the definite integral. We're going to add k times delta x, which is 2 over n. And our delta x is 2 over n. We're going to replace, or I should say put that out here. This goes in brackets. And we could simplify that, if you'd like, to 2k over n, like so. We went from sine of x in the integral to sine of x on steroids, multiplied by delta x. Next, we are given this Riemann sum, and we are asked to move to the definite integral. And as always, we're going to refer to this equation here on the right. Okay, so look at this. We have the Riemann sum of cosine of x on steroids. We're going to change that to simply cosine of x. Now, what we need to do is use what's inside here. Use the steroids, if you will, to find a and b, and we will be done. Okay, so here we go. We know that that is a. Okay, look at our formula over here on the upper right. That's our a value. So we know that a is equal to 0. The other thing we know is that we have k times delta x right here, and then we have delta x on the outside. So it's very clear that our delta x equals pi over n. Okay, so all we need to do is find our b value. We already know that our a value is 0. So let's figure out what this b value is right there. Well, we know that b minus a over n is going to equal delta x. And we know, based on looking at this Riemann sum, that delta x equals pi over n. So if we match up, if we match the numerators, we know that b minus a equals pi. We already know a equals 0. So here in pink, we're going to have b minus 0 equals pi. Therefore, b must equal pi. So we're going to replace this question mark with pi, and this is the definite integral that's going to match that Riemann sum.
This is a difficult problem. We're given this Riemann sum and we're asked to find the definite integral. So what makes this difficult is we have two functions here. We have the square root function, and then we have another function within that function, namely something is squared. So at first glance, you may say to yourself, well, this is a plus I delta x, and that's your a, but that really doesn't fit. What we have to say to ourselves is this is where the steroids were plugged in. So our integral had an square root for sure. It had the 1, and here's where the x was, right there. So when we went from the integral to the Riemann sum, this is where the steroids were plugged in. The other thing that tips us off is we have this 8 over n outside. That means that's our delta x. So that means this is our delta x being multiplied by a, and there's actually a 0 within the steroids. So what was plugged in here, folks, is 0 plus 8 over n I. So we're going to use this information to get our a and b value to plug into that integral. Okay, so we know that our a value equals 0. We know that b minus a over n is going to equal our delta x, which again, it's obvious because it's outside here, is going to equal 8 over n. Therefore, we're going to have b minus 0, because we're going to pattern match with the numerators. B minus 0 equals 8, and b equals 8. So therefore, our final integral is going to be from 0 to 8 of this function times dx. Next, we are given this definite integral, and we're asked to find the Riemann notation. We're going to use this formula on the upper right for our pattern. First thing we recognize is that we're going to change from f of x to f of x on steroids. So this first part here is always the same. The only thing that changes is whether or not you're using k or n. So what I'm going to do, folks, is I'm going to rewrite the original function from the integral. And what we're going to do is we're going to take this x out from the original integral, and we're going to replace that x with the steroids. Okay, what are they? Right here, a plus k delta x. So we need to find that. We need to find a, and we need to find delta x. Okay, we have a. They give it to us right there. So we know a equals 4. And delta x is going to be obtained by using this formula, b minus a over n equals delta x. They gave us the b, that's 5. So we're going to have 5 minus 4 over n, or 1 over n. Okay, so we have our delta x equals 1 over n. We're going to take this word out. Okay, I'm going to move that plus 1 over to emphasize that that plus 1 is not changed. Look, that plus 1 from the integral comes right into the Riemann sum. We're plugging in for that x only. And what are we plugging in? We're plugging a plus k delta x. And in this problem, our a is 4. There's your k, and our delta x is 1 over n. So you could simplify this by saying 4 plus k over n. The textbook that I saw left it like so, meaning they didn't combine the 4 and the 1. I'm going to leave it like this as well, because this emphasizes that this used to be our x, and we replace that with this notation right here, and this 1 has been left alone from the original integral. And don't forget, we got to multiply by dx, delta x, which we know is 1 over n. Next, we are given this definite integral and asked to move to the Riemann notation. We have the limit as n approaches infinity, summation k equals 1 to n. Okay, and what I'm going to do is I'm going to rewrite f of x from the integral. Okay, I'm going to take this x out, and I'm going to replace that with a plus k delta x. I'm going to leave that plus 1 alone. Okay, so we need to find our a, we need to find our delta x. We know that a equals 0 and b equals 5. B minus a over n is going to be our delta x. That's going to be 5 minus 0 over n, or 5 over n. Okay, so we're going to replace the original x that we removed from the f of x that was in the integral, and we're going to replace this with a, which is 0, plus k times 5 over n, and that's going to simplify to 5k over n. And we're going to take this, and that's going to be squared. And then, of course, we have to multiply by delta x, and we know that to be 5 over n. Folks, this is the matching Riemann sum. Folks, as I went to erase this, I realized that this should be in parentheses, emphasizing that that squared is going to apply to all the factors within the parentheses. Next, we are given this Riemann sum and asked to find the definite integral. Okay, so what do we have here? We have this here, and we have this on the outside. That tells us that that is our delta x right there. So we know delta x is going to equal 1 over n. And as we look at this, we recognize, folks, that these are the steroids right here. So they have this reversed. They have this as, it really should be a plus k times 1 over n. But they have these reversed. But this is still going to be our a value. And we recognize this as the k times 1 over n. Okay, so what do we know? We know our a value equals 4. And we know our delta x equals 1 over n. From that, we can glean the b value. Okay, let's go ahead and do that. We know that b minus a over n is going to equal delta x. And in this case, our delta x is 1 over n. We're going to pattern match the numerators, and we're going to say b minus a equals 1 in this problem. B minus 4 equals 1, therefore b equals 5. So we know, folks, our definite integral is going to go from a, which is 4, to b, which is 5. Okay, now, how are we going to write the integral? Well, this has the steroids in it. That means it used to be x. So the original function is going to be 3x plus 2 times dx. And folks, that is your definite integral. Next, we are given this definite integral and asked to find the Riemann sum. Okay, so the first thing I'm going to do, folks, is I'm going to copy the f of x right from the integral. Like so. Then I'm going to recognize that the Riemann sum means we're going to take that x out and replace it with a plus k delta x. We're going to take that x and replace it with a plus k delta x. Okay, to do that, we need to find our a and we need to find our delta x. Folks, the a value they give us, the a value is 2. Okay, the delta x is going to be b minus a over n. That's our delta x. Well, they give us the b value as well. The b value is 7. So delta x is going to be 7 minus 2 over n, otherwise known as 5 over n. So we're going to take this and we're going to do k times 5 over n. Here's your a. 2 plus k times 5 over n. And we're going to simplify this to 2 plus 5k over n. Folks, this is what we're going to place into the function instead of x. So let's go ahead and do that. Let's remove the x in each term here. Okay, we're going to take this x out right there, and we're going to replace it with this right here. And we're going to do the same thing with this x. We're going to take this x out, and we're going to replace it with that. Okay, went ahead and did that. I took a plus k delta x and replaced that, put that in for x in both places. And then folks, finally, I want you to notice I put a bracket around all this, and then there is our delta x. So this is your final answer.